Hi students, this is Mr. Metelsky, and today's video will be about solving systems of equations by graphing. So typically this method is good when you already have equations that are in slope-intercept form. So if you remember our good old y equals mx plus b, the m value here is the coefficient of x, so that is our movement. So if we have a slope value of 2/3, the top number tells us to go either up or down. Well, since it's positive, we're going to go up 2. Bottom number always tells us to move to the right. The b, or the y-intercept, you could think of it as the beginning, is going to be at the second number, or 3. So that will be at 0, 3. So what we do is, to plot this line, we are going to put a point at 0, 3, which is right here. And we're going to do a slope of 2/3. So up 2, right 1, 2, 3. Up 2, right 1, 2, 3. Up 2, right 1, 2, 3. And we could continue that. Instead of going up 2, we could go down 2, left 2, 3. Down 2, left 2, 3. Down 2, left 2, 3. Okay, so we have our first line on there. Use our ruler or something straight to connect all those points. So we construct our first line. Okay, we do a similar thing with the second equation. Now, the second equation, you might look at the number in front of x. Like here, it was sort of easy because it was 2/3, it stood out. But here we only have a negative sign. So we need to remember that this really means -1 x. So I like to put in that invisible 1. And because there's no denominator, or the denominator is invisible, we could technically put that over 1. Because I'm not changing anything by putting it over the number 1. So that means the slope value is -1 over 1. So negative means down this time instead of up. Down 1 and then right 1. The b value, where we're going to have our y-intercept, or the beginning, will be at -2. So 0, -2. So let's take a look at our graph. We're going to begin at 0, -2. That would be right here. And we're going to go down 1, right 1, down 1, right 1. So we'll do that a few times. Down 1, right 1, down 1, right 1, down 1, right 1. Sort of figure out the pattern by now. It just keeps going down that way. And if we go the other direction, we go up 1, left 1. So up 1, left 1, up 1, left 1, up 1, left 1. Oh, that's a shared dot. Up 1, left 1, up 1, left 1. And again, you can put our ruler on there and construct our line. All right. Now, in order to solve a system by graphing, you identify the point of intersection. Identify the point of intersection. So for us, these two lines crisscross right here. So we just need to find the location of that point and write it as an ordered pair. It's always proper to write it in ordered pair notation. So this is going to be -1, 2, 3, and up 1. So -3, 1. So that means that that answer is a solution to both the top equation and the bottom equation. So if we were to plug those values in, we should get true statements. Okay, true statements. So what do I mean by that? Well, let's take a look. So our first equation was y equals 2/3 x plus 3. And if we take this as our x value and this is our y value, and we substitute them in, hopefully we'll get a true statement. So y is 1, so that'd be 1 equals 2/3 times x, which is -3, plus 3. So I'm just swapping out the x and the y for -3 and 1. Now over here, 2/3 of -3, that should be -2. So we get 1 equals -2 plus 3. And -2 plus 3 is 1, so we get 1 equals 1. So that checks out. So we can do the same thing now for our second equation, y equals -x minus 2. So y equals -x minus 2. So for the y, we're going to put 1. Negative, the x value is -3. Bring down the minus 2. -3, that means the opposite of -3, which would be +3. So 1 equals +3 minus 2. And we know 3 minus 2 is 1, so 1 equals 1. Check. So now we've identified the point that's a solution because it works and creates a true statement in both of the original equations. All right, good luck.